All right, this is take number 2 of the scientific notation. This is the first video in the pre-physics unit. Apparently, the last video froze, so I'm going to try this again. Scientific notation is used when we're writing very large numbers and very small numbers. By very small numbers, we're talking about numbers that are between 0 and 1. We're not talking about negative numbers. We're just talking about things that are between 0 and 1. So it's all based on powers of 10. So first off, we have 10. This would be 10 to the first power. It's not 10 to the 0 power. That would be 1. Anything raised to 0 power is 1. So 10 is 10 to the first power. 100, what we have is 10 times 10, or what we would call 10 to the second power. With 1,000, 10 times 10 times 10, it's 10 to the third power. Up here we have a million, a 1 with 6 zeros behind it. This is 10 to the sixth power. We have a billion, 10 to the ninth power. These are all what we would consider large numbers. They are all greater than 1. Then we have things that are less than 1, between 0 and 1. This 0.1, in math we would call this 1/10. Or you could say 1 over 10 to the first power. When you have a positive exponent on the bottom of a fraction, you can express it as a negative exponent. We're going to call it 10 to the negative first power. 0.01, this is 1/100th, or 1 over 10 to the second power. We could say 10 to the negative second power. 0.001, that is 1/1000th, or 10 to the negative third power. When we're going to write a number in scientific notation, there are 2 basic steps. First step, move the decimal point until you have a number between 1 and 10. Second step, multiply that number by a power of 10. So your exponent is going to be the number of places that we move the decimal. The sign of this exponent is going to be positive if we had to move the decimal to the left, and that means we have a big number, or something greater than 1. The sign of the exponent is negative if we had to move the decimal point to the right, which means we have a small number, or again, something between 0 and 1. Some examples here using the procedure that we just outlined. For the number 23,000, our number between 1 and 10 is 2.3. We're going to multiply that by 10, and the exponent is the number of places we move the decimal. We're going to move the decimal to the left, which means it's positive, and we're going to move it 1, 2, 3, 4 places. We end up with 2.3 times 10 to the fourth power. Here we have 2,300,000. Again, we start with our number between 1 and 10, 2.3. Multiply it by 10, and we're going to give it an exponent. Again, we're moving the decimal to the left, which means it will be positive, and we are moving it 6 places. 2.3 times 10 to the sixth power. 0.000033. This is a very small number. It's going to work the same. My number between 1 and 10 is 3.3. Multiply that by 10. The exponent is going to be negative because we have to move the decimal point to the right. We have a small number. We're going to move it right 1, 2, 3, 4, 5, 6 places. We find 3.3 times 10 to the negative 6th power. Next one, 240,000. My number between 1 and 10. Multiply it by 10. We're moving the decimal left, which means positive exponent, and we're moving it 5 places. 2.4 times 10 to the 5th power. 7 trillion. A lot of times in physics, you'll get a textbook where they express things like this, 7 trillion. So we have to know how to put this in scientific notation. So there's really 2 methods you could use to do this. First method, if you just happen to know that trillion is times 10 to the 12th power, then all you have to do is add that in here, 7 times 10 to the 12th. Or if you don't know the exact, then you could put it in standard notation first. 7,000 million billion, there's 7 trillion. And so we put 7, that's a number between 1 and 10, times 10, and we're going to move the decimal place to the left 12 places. And so either method, we're going to come out with 7 times 10 to the 12th power. 0.00028. My number between 1 and 10, 2.8. Times 10, and the exponent is going to be negative. I'm going to move the decimal point to the right. It's a small number. 1, 2, 3, 4 places. 2.8 times 10 to the negative 4th power. 78 million. This is a lot like the 7 trillion idea. You could write it in standard notation if you want, or if you just happen to know that million is times 10 to the 6th power, that's helpful as well. Something to be careful of, if you were to write 78 times 10 to the 6th power, this is not standard scientific notation. My number, the problem here is that my number is not between 1 and 10. So we have to make an adjustment. So I have to change it. 7.8 is my number between 1 and 10. Times 10. And here's what we're doing. I have to move the decimal place to the left 1, which means that my exponent is becoming more positive. It's going to be times 10 to the 7th. When you move the decimal to the left, your exponent is going to become more positive. 650,000. So start with my number between 1 and 10. Times 10. Moving it left so it's positive, 3, 4, 5. 6.5 times 10 to the 5th power. This number, a lot of zeros. It's a very small number. My number between 1 and 10. Multiply it by 10. Since I'm moving the decimal place to the right, because it's a small number, the exponent will be negative. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. 8.9 times 10 to the negative 10th power. Here we have 2,500 times 10 to the 7th power. This is going to be somewhat like what we did with the 78 million. So we have a decimal that is here, and we have to move it left 3 places. So my number between 1 and 10 is 2.5. Multiply it by 10, and then the exponent is going to change. And here's how it's going to happen. we're moving it left, my exponent is becoming more positive. So we're at 7, now we're at 8, now we're at 9, now we're at 10. We find 2.5 times 10 to the 10th power. And this next one, 920 times 10 to the minus 7th. So with this one, what's going to happen? First off, my number between 1 and 10 is going to be 9.2 times 10, and now we have to figure out what the exponent is going to be. So we're starting at negative 7. So at this point here, it is negative 7. And as we move it to the left, it's going to become more positive. So we have negative 7, negative 6, negative 5. And we find that it is 9.2 times 10 to the negative 5th power. 0.000067 times 10 to the minus 3. First off, I have to make this a number between 1 and 10. That would be 6.7 times 10. Now we have to figure out the value of the exponent. So at the current place, we are at negative 3. When you move the decimal place to the right, the number is going to become more negative. So I'm at negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. 6.7 times 10 to the negative 8. So using your calculator, if you're using a school-issued calculator, which is at this school a TI 30XS, you're going to need to put parentheses around every use of scientific notation. Somehow the order of operations will change if you forget that, at least with multiplying and dividing. So we're going to put these in our calculator. 6.1 times 10 to the 7th power plus 7.2 times 10 to the 6th power. We have 6.82 times 10 to the 7th. With the significant figures rules that were from the problem, we would find this as 6.8 times 10 to the 7th. Significant figures is one of the next videos in this pre-physics unit. Here we have 2.2 times 10 to the 4th power, 3 times 10 to the 11th power, and times 10 to the 8th power. So what we're going to do here, we're going to use our calculator. But if you weren't going to use your calculator, the first thing you would do is just multiply all the coefficients. So we have 2.2, 3, and no coefficient here, which just means a 1. So 2.2 times 3, and then we put our times 10. And since we are multiplying, we are adding the exponents together. 4 plus 11, there's 15, plus 8 more gives us 23. And again, if we were doing significant figures rules, this would actually round to 7 times 10 to the 23rd. Over here, we have 2.4 times 10 to the 12th power times 10 to the 5th divided by, don't forget your parentheses, 3 times 10 to the 6th power. So if you are going to divide scientific notation, you are dividing the coefficients. So we have 2.4 divided by 3. That would end up being 0.8. We're going to put this in our calculator. And so we end up with, just as an estimate, we're going to add these two exponents because we're multiplying, so 17. And when you divide, you subtract, so minus 6. So just based on my mental math version, I would have 0.8 times 10 to the 11th. And we have to fix it because that's not standard scientific notation. It ends up being 8.0 times 10 to the 10th power. Next one, we have 2.3 times 10 to the minus 5th minus 1.2 times 10 to the minus 4th. When you're subtracting scientific notation, the exponent on the power of 10 needs to be the same. So both of these would need to be either 10 to the negative 5th or 10 to the negative 4th. You'd have to adjust one. Putting it into the calculator, we find that our number is negative 9.7 times 10 to the negative 5th. We have 4.0 times 10 to the 5th, and we're going to square this. So when you square a quantity of scientific notation, we are going to square the coefficient first off, 16. And we are also going to multiply the exponents. So we would come up with times 10 to the 10th power. If you did this in your calculator, it would adjust it automatically. As we're looking at it here, this is not standard scientific notation because my number here is greater than 10. So I need to adjust it, 1.6 times 10. And remember, it becomes more positive. The exponent becomes more positive when we move to the left. It's going to make it to the 11th power. Here we have 1.2 times 10 to the minus 3rd. We're going to square that whole quantity. Again, so we're going to square the coefficient, and we are going to multiply the exponents. So put it in the calculator, and you would find 1.44 times 10 to the negative 6th power.